Hello, everyone. Welcome to today's webinar on connected manufacturing, improving quality and throughput with digital twins. My name is Matt Hine. I am Vice President of Product at Vertex, and I am joined by my colleague, John Heller, who is a Product Marketing Manager with Vertex. My background, I have a academic background in mechanical engineering, but I've spent the last 15, 20 years working on software related to mechanical engineering. I've done a lot of work specialized in 3D data visualization, data science, machine learning, and spent a number of years working in the cloud computing space. At my previous company, Workiva, we built the first B2B application on the Google Cloud platform. And I am also joined here by John Heller. And John, if you could introduce yourself.
Absolutely, thanks, Matt. So similar to you, also have a academic background in mechanical engineering. I've worked for two major manufacturing companies over the course of the last 18 years, one being Dassault Falcon Jet, supplier of private business jets, and then as well as more recently before joining Vertex at Danfoss, which we supplied. We were a tier one supplier to the off-highway mobile equipment industry. And through those two companies, held various roles in product development, supply chain, as well as improving the manufacturing processes out on the shop floor. So back to you, Matt.
Thanks, John. I'm going to start off with a slide kind of outlining the digital thread vision as we've been talking to our customers, industry experts, and our prospects. This webinar series is the first of several in our kind of connected webinar series here. Really what we're talking about with the digital thread, and I know a lot of people have different definitions of the digital thread. For the purposes of this webinar, the digital thread is the connected web of people, processes, and data. All of those things are creating digital artifacts. All of those digital artifacts are related to the product in some way, and the digital thread's the way to keep all those things together so that you can trace and query across that entire life cycle of the product. On the right, we have this diagram that we often use within Vertex to kind of illustrate how we see the digital thread. We've got the different departments across the top. I know there's some other departments not necessarily listed here, but if you think about from start to finish of the product, going from that initial design engineering to manufacturing, to aftermarket, and even now customers are also generating digital artifacts in the field as well. Across the bottom, we talk about these things as being systems of record. So PLM, MES, ERP, CRM, IoT, to name a few. IoT can be, factory IoT. It could also be product IoT coming from telemetry. But in reality, this vision is great because you can connect all these things together if you can do it. And there's all types of improvements that you can make. In future webinar series, we'll be talking about sales and marketing, how to, be able to do better engineering to order, configure, price quote type applications, creating market ready geometry and things like that. We'll also be talking about aftermarket service and predictive maintenance, engineering, design collaboration, and just, kind of building digital twins. Today, we're going to be specifically focused on manufacturing for the rest of the webinar here. So, within manufacturing, a lot of the effort with the digital thread, I can think of, really, I think it starts with, can I get a model-based definition to the shop floor? Engineering has done all of this work to create this design specification, And yet when it leaves engineering and goes into manufacturing, there can be all of these issues with handoff there. I think, first thing, work instructions, for example, and we'll show a couple of examples of this later on. You've done all this work to create these 3D models within engineering. Why is the shop floor still looking at 2D drawings or text-based instructions, or maybe it's just photos of what it should look like, right? And there can be some challenges with that, and we'll touch on that in a second. The other thing is I would think about quality. How can you better ensure quality? An issue that you find before it goes to the next station, or even off the line out of the factory. The longer it takes to find that quality issue, the more costly it's going to make, and we'll show you some examples of improving the quality feedback there. I also we talk a lot about factory digital twins and being able to visualize processes within the plant. Predictive maintenance, understanding different data coming off PLC controllers and things like that. And also, there's also this idea of DFX, right? Can I have this feedback loop between manufacturing and engineering and have a collaborative kind of experience where we can, talk to each other and, decide, how to tweak the design to make it easier to assemble, easier to manufacture, things like that. And lastly, we'll touch on, let's just say knowledge base and training for the factory workers. So, making sure that they know exactly what they're building, that they understand all the safety measures, that they're well trained before they even start working. And so we'll go through a couple of these examples. And this is kind of where what we actually see in reality here. Instead of this connected web of this digital thread, I kind of think about this as this frayed digital thread where you've got multiple branches peeling off, and you end up with siloed departments, both I would say from a technical perspective. A lot of times these systems are not necessarily connected together. The output of one process is not going into the input of another process, just because of architectural issues with the software systems. But these siloed departments and barriers can also be cultural in nature. So can I maybe engineering, design engineering's in a completely different country. Maybe they don't even speak the same languages as us. So how do you do that collaboration? How do you make that truly efficient? The other challenge that we see quite a bit is just lack of true enterprise PLM access. And the promise of PLM is that you can have everyone in the company be able to have access to that data and be able to tap back into that data source. But we often find that because of either licensing considerations, or maybe probably more importantly, the user experience, the user interface is just too complex for those untrained users. It's very cumbersome to find things. You don't know how to use the system. And then I would also say that going back to those technical challenges, oftentimes within software engineering, we'll talk about the API, the application programming interface. Really, that is that communication layer that allows two systems to be able to talk to each other and be able to read data from one and write data to the other and vice versa. Oftentimes, a lot of these systems just have not been designed well to be able to take advantage of those. Maybe the API doesn't even exist for some of these systems, or maybe you have to create, a third kind of middle data lake or data warehouse to be able to do that. So I'm going to turn it over to John, and he can specifically talk about some of the challenges that we see in this digital thread.
Yeah, thanks, Matt. So, if we were to sum up the digital thread reality into sort of a core problem statement based off of what Matt just walked through in this previous slide here, it all comes down to the inability to effectively move and connect the data. I've heard the word viscosity mentioned in quite a bit of circles and conversations that we've had with customers and prospects, that the data is just too cumbersome to move. It's too big, it takes too much effort to move. And once you do move it, it becomes extremely difficult to be able to make applications that take that data and do something meaningful with it. It's also very difficult to connect these downstream teams. Once you're able to perhaps move that data, then it becomes extremely cumbersome to connect your teams to it. And that's brought about by the fact, as Matt mentioned earlier, about this complex user interface. There's no interactivity. It's very difficult to interact with that data. We see that the core of this is really brought on by the fact that in efforts that manufacturing organizations are taking to become more of a model-based enterprise and move into a model-based definition on the factory floor, requires special hardware, requires special software to be able to handle these large data sets. And that becomes extremely challenging, time-consuming, and expensive for organizations to take on. So moving here into how Vertex solves that, we see that Vertex enables your product data now to be communicated all along the digital thread. We free those constraints that are brought on by complex user interfaces. We free the constraints of always needing to rely on expensive hardware and software to be able to move the data, view the data, interact with the data. We're able now to deliver that information with no real data transformation needed. And then once that data is out there, Vertex provides very quick and easy ways to be able to build interactive digital twin experiences that connect all of your teams to that data, providing the valuable insights that your teams need on the manufacturing floor. So with that, we'll move into a couple of examples now. Working in some demo, Matt's going to do some demo here. If we look at a couple of key problems that we see in being able to do practical applications out on the shop floor, the first one we hear a lot of is being able to create these interactive work instructions. Matt alluded to it a little bit earlier. I think manufacturing teams understand the importance of having interactive work instructions, but the actual deployment of these in a meaningful manner is where the challenge comes in. And that's brought about by the fact that there still remains this disconnected link between the source of information and the shop floor. We also see that there's challenges in the ability to be able to understand the data out on the shop floor. And this again is because there's too many barriers to being able to have a true model-based definition out on the shop floor. You've got, as Matt mentioned, 2D drawings, perhaps photos. You've had to scrape out so much information from the original design intent just to move that data out to the shop floor that there could be missing pieces of key information that are needed to effectively manufacture and assemble. And then there's a lack of feedback from the shop floor back to engineering. Being able to then, what we call move the needle in a positive direction to say, okay, this process worked okay. We're able to hit this tack time, let's say, on assembling this, but we see all these other areas of improvement, but we have no way of effectively communicating that back to engineering to do something meaningful with it. So turn it over to Matt to show how we're solving that solution with Vertex.
Yeah, thanks, John. So what I'm going to do is, and I'm going to head over to our developer portal. So this is the Vertex platform SDK developer portal. And within here, we have some examples of different applications that we've built and open sourced on the Vertex platform. And the first one here is 3D work instructions. So I'm going to click on this and then click Launch App. And by the way, you can also, if you're technical or you have some developers that you work with, all of these examples are available on GitHub. If you click the view on GitHub, that can take you to the application code itself. So I'm going to click Launch App here. So what we're seeing here is an application that we built for the Vertex platform for 3D work instructions. This is 100% cloud-based, so all of the data that you see here is actually being rendered server-side and streamed back to my web browser. That's pretty important for some of these connected manufacturing applications where you might have underpowered or low-powered devices, specifically within the factory itself. So you don't have the same workstation or high-end workstation laptop with the same hardware. So think about thin clients, iPads, and even mobile phones now, right? So what we can do is take something, and by the way, this car here, this is a kit car from Supercar Systems. We've rendered and been able to pull out data sets as large as airplanes, and so we haven't come across a data set that we haven't been able to pull out of that PLM system and display it within a web browser. So what we have here, I'm going to click this Begin Assembly. And what we've done is taken a subset of the work instructions and just kind of showed an example of how to build these. So basically what we've done is created a connection to the PLM system to pull out the exact work order configuration for this VIN number, let's say. And with that, I can also use an API to be able to pull the actual instructions from, sometimes it's in the MES system, sometimes it's in the ERP system, but somewhere there is, the list of instructions to enable step-by-step kind of go through the build process and, or the MBOM. So what we have here is just a snapshot to show each of these steps as we go. And if I'm installing this, the spindle on here, we can just kind of step through it. The other cool thing about being able to do this type of stuff is, when I actually click in the window here, I'm actually I can get the part number. So I know that's, and we'll talk about that in a second. It's very important that you give the operators the ability to kind of interactively explore and be able to select different things for different types of applications. And then I click next here, and then I can say done. And again, this is 100% Vertex platform being able to pull out that data, connect that to that ERP system or the MES system to get the actual instructions, and then you can build applications like this either for let's say actual production, or we have some customers that are building these types of applications for training, for both the shop floor and field service. And I will turn it back over to you, John.
Thanks, Matt. So another topic that we hear a lot from our customers is, how do I ride this wave of digital transformation to improve quality? In my former roles, working with Danfoss and with Dassault FalconJet, we talked a lot about quality. I mean, that goes without saying. The cost of quality was forefront in everyone's mind. Additionally, we did not want to put a machine down out in the field. Field retrofits are very expensive, and that was the #1 goal when we went through the manufacturing processes, as well as these design for assembly, design for manufacturing, was making sure that we prevented field retrofits. But the problems that I saw creeping up in an effort to move the needle with quality was that we're still dealing with disconnected data. We have antiquated processes for tracking defects on the line. I've seen sticky notes, I've seen Word documents, I've seen Excel spreadsheets trying to keep track of defects on the line. I've also seen just hand scribbled notes in someone's notebook that are just sort of passed on, this tribal knowledge. And as we discussed earlier, maintaining that knowledge and expertise on the shop floor is becoming increasingly difficult when you have these disparate data sources with no central way to view that data. There's also, we're living in a global manufacturing environment. There's multiple product lines within a single facility, as well as multiple product lines spread across all of the globe. How do we roll what we're seeing from a defect standpoint across all of our product lines into one single view so that we can make quick and actionable decisions? We're also seeing that there's no way to really connect your ERP systems, your MES systems with your supplier systems into a single view to be able to roll that up in a way that you can make actionable decisions to improve quality. And so I'll turn it back over to Matt for a look on how we're doing that.
Yeah, thanks, John. So one of the applications that I was saying, you could layer on top of the work instructions app, for example. If you've got your workers in here going through each of these steps, like I said, they can interactively select different parts within these work instructions, right? So if coming in here, if I get to this step and I realize, hey, on the last step, I actually stripped these bolts, or maybe it wasn't me. It's often not you, right? So maybe the person that before you was the one that actually stripped the bolts. So what you can do is click report issue, and anything that you have selected can come over with this part identifier. So, again, if I think of all the digital thread lineage and connectedness, a lot of times it's basically connected back to either a configuration or the tail number or the VIN number, the serial number for the product that's built. And within that, the part numbers that are used to build up that final assembly. And even interesting, sometimes in some industries like aerospace, these part numbers may even have their own specific instance and certification lineage that you can connect to. So what I can do here is then when I log this issue and report this issue and submit this back into the system, again, like Vertex is simply giving you this user interface to be able to create these applications. We're not storing this issue. So when I click submit issue, that can go back to the ERP system or your issue management system, whatever it is. And then now at that point, now you can build up a collection of these and actually have high quality data because that part number is connected there. Maybe the operator's connected, you know what time of day everything's happened. So you can do some really interesting things with data science and data analysis to be able to back out where are these issues originating. And once you kind of have that list of quality issues built up, you know, you could also give this same set of work instructions to the repair bay, and they could actually pinpoint on this model where exactly, you know, not just the part number, but you know, an XYZ location on that part itself, so that they can you know, see it directly. We've also been working with customers where, let's say, if it is you know, if they do have an iPad or a smartphone that they're displaying all these instructions on, you know, you could even snap a photo of that and attach it to that 3D object and be able to deliver that back to the repair bay. On one of these other examples that we have on our developer portal is 3D visual analytics. And we built this application because we've run into a few different groups at some major manufacturers that have started to do some data science analysis on their product. And, you know, I often hear some of the steps that they go through. You know, they'll export out a JT file, maybe strip off all of the 3D information on that, inject that into some data analysis tool, let's say something like Tableau or something like that, run an analysis, get the results, and then inject that back into the JT file to visualize it. So one of the things that we thought we could kind of show off how the, you know, Vertex platform can help you do some of those things. We built this application where if I've got a list of data connected to part numbers, could I just visualize that in context on the model itself and create a heat map? And, you know, tying this back to this quality use case, we've got some customers now that will take all those defects that are being created on the shop floor and then also kind of visualizing them in place. And so for let's say for the factory manager or for you know, the manufacturing engineer that's looking at different process improvements and trying to minimize these defect and quality issues, you know, you can start to build up some of this information and really get some advanced knowledge of what's happening. And I can even, you know, tie this back to maybe some of my suppliers as well, right? And so I can really start to build up that story of what's happening with quality within my product. With that, I'll give it back to you for one last demo slide here, John.
Thanks, Matt. So as Matt said, we'll look through one more problem and example here. There's no denying that data sets are growing larger. We've hit on that leading into this discussion. I've been a part of several projects with my previous companies where we were super proud of ourselves that we collected a bunch of data, but then we had no idea what to do with that data. We didn't know which data to look at, how to synthesize it. We didn't know how reliable it was, where was it pulled from, how up to date was that data. So we see that continues to be a problem from a lot of customers that we talk to about, okay, I've got this data, which one do I look at? How reliable is it? Then it's a challenge of, okay, now that I've got it, what do I do with it? I have all of this data. How do I gain insights from this information? And then we see as manufacturing organizations and environments become much more digital, starting to ride this digital transformation wave, a lot of your company's proprietary information may be included in the GD&T information as you attempt to become a model-based definition floor. And so the questions start creeping in. How do I keep this data secure? How do I not let my proprietary information out of my grasp? And so we'll look to Matt here for another example.
Yeah, so I kind of touched on some of these in the last demo, but you know, there's in my mind, a couple different types of data. One is relational, and we kind of showed some of the relational data. You can think of relational as being able to have certain records tie back to other records and be able to build up queries that way. Another interesting type of data within, specifically within manufacturing, is time series data or time-based data, in which maybe you have a process, a machine, a piece of a machine, a sensor that's generating data over time. And so what you can do with that is, again, tie that back to, let's say, either the actual factory or back to the product itself. And I'll show a couple examples of that here. I'm just going to pull up this lightweight factory example that we created. So imagine here's your shop floor modeled. And by the way, I know a lot of you, there's a lot of companies out there that would like to have their entire factory modeled in 3D. And, I know that's not always the case, but Vertex also has the ability to be able to pull in point cloud LiDAR scans of the factory. So I think that's one new type of way to be able to visualize your entire factory. Is instead, again, if you don't have the CAD, I could do a LiDAR scan of the entire factory and be able to create 3D assets from that LiDAR scan. So what we've done here is just taken some of the factory data and then looked at maybe a time series analysis of efficiency by station. And so with this, you could give this type of experience to the factory manager to help them understand, station by station, where's my throughput bottlenecks, where, the health of different machines, the wear of different tooling on those machines. And over time, you can start to build up really some interesting analytics and insight here, and connect that to some really pretty interesting applications out there that are creating predictive maintenance based on artificial intelligence to help you predict where future issues might occur. With that, we're about out of time here, so I'll just quickly go over the final slide here. So, we've talked a lot about use cases on the digital thread, and the Vertex platform can help you create a more connected manufacturing environment. We're unique in that we can build web-based applications on with any type of product data at massive scale, either in terms of numbers of users or the data set size. Like I said before, we've been doing a lot of work with companies that are creating assemblies well over 100,000 parts, and doing that on a factory production scale. We support model-based definitions with PMI and GD&T, so you can deliver those to the shop floor. We have a really easy to use platform API and SDK, but we also have a turnkey solution to help you get started right away. And ideally, we're best suited for Industry 4.0 applications where you're connecting, let's say, data from engineering plus data from another system, and delivering that to mobile and low-powered devices. And with that, I'm going to turn it over to John, because I think we have a few questions coming in.
Yes, absolutely. We do have a few questions here. The first one is, can you talk through some of your security best practices or certifications, please?
Yeah, I'm glad that question came up. I didn't really have time to touch on this too much. Obviously, when you talk about the digital thread and uh, all the information within there, especially thinking about the data coming out of design engineering, like that, the actual CAD PLM data. That data is probably some of the most IP, intellectual property sensitive data sets within the organization. Like it's literally the blueprints to the thing that's creating revenue for your company. And we take that very seriously. And if I think about some of the other systems out there that allow you to build digital thread industry 4.0 applications with that data, what's unique about Vertex is our inherent architecture allows that data to stay in one spot, and you're simply just streaming information from that data set. Versus some of the other systems out there, you're actually taking that sensitive information and actually delivering all of that data to the device itself. So the difference is, think about, I don't know, I think of, all analogies are not great, but, in terms of, what we're doing, think about having an entire movie actually downloaded to a device versus something like Netflix where you're just streaming the movie to the device. Once you download the movie, you can do basically whatever you want with it, and that's how movies end up on the internet, right? And same thing with your CAD data. So
yep. All right, great, thank you.
The other aspect of security, that's just kind of inherent with our architecture. The other aspect is we're Vertex. The Vertex solution is, as the industry calls it, a SOC 2 Type 2 certified solution, which basically is all of the internal controls of Vertex to ensure that that our code is secure, that the way that we deliver our code is secure, and things like SLA and uptime and things like that. That's all built into that SOC 2 Type 2. And so we've got a number of certifications there. And another thing that's important, especially for, let's say, aerospace and defense customers, our solution is available to handle ITAR restricted data, and we do that through the AWS GovCloud. Yep.
Awesome, thank you. All right, I think we got time for just one more here. Let's do, so what's special about the Vertex solution? Why can't I do these things with my PLM?
Sure. I mean, maybe you can do them with your PLM, but if you can already do them with your PLM, you're probably not here interested in Vertex. Like, I think there's a lot of applications that people have tried to build with the some of the PLM providers SDKs, and I think at some point you got to think about I would say their goals to kind of keep you within that ecosystem itself. Vertex, we want to have an open API architecture where we can connect to any system. We connect to all the major PLM providers. We read in all of those native CAD formats as well as the neutrals. And our API allows you to connect to a number of these other solutions to build those 3D word construction applications. I think the other thing that's just unique that we provide, and I think this goes back to just our architecture, is designed from the ground up to support some of these modern industry 4.0 type applications, and thinking through data security, delivery to low powered devices. Some of the low powered devices, probably like a smartphone, weren't even around when a lot of these major PLM architectures were put in place. So we've really designed this to be a feature forward solution.
All right, thank you. All right, I think that's about all the time we have for questions. So I want to thank everyone for attending. Matt, do you have any final closing comments?
This is actually, our first webinar in a series here, and in the next coming weeks and months, we'll be kind of talking about solutions for some of those other departments that we talked about at the beginning. So if you're interested about this webinar or any future webinars, please reach out to John and I, and we'll get back to you. Thank you, everyone.
Thank you.